All right, ladies and gentlemen, these are the notes for Friday. I'm gone today, so I want to make sure that you have these notes. I am not going to give you homework from these notes because you're going to start a project today, but you do need to know how to do these for a quiz that you're going to have on Monday. You need to know what this is all about. And these are different types of shape, and we're going to kind of go through this whole packet. You'll see everything. 3 different types of shape. 1, 2, 3. And the words are skewed left, symmetric, and skewed right. And skewed, maybe I'll write this up here, skewed just means tails in that direction. So it's like you're going to build like a hill over all of this data wherever you see it, whether it's a dot plot and you kind of form a hill. You see what happens here. The majority of the information is right here, but it is skewed off to the left because it tails off to the left. Hence tails left. And again, I'm going to write tails off to the left. Okay. Same thing happens here. Again, you maybe can't see it here because I'm going to draw this line, right? It's kind of, if I kind of follow the hill here. Okay. Maybe you don't see it there, but if I turn the information on its side, I can see that this is tailing off to the left. Okay. So this one is skewed left as well. Okay. All right, so I look at the next one, roughly symmetric. It's exactly what it sounds like. It's supposed to be symmetric. So, draw like this. Now, it doesn't have to be perfect. The word here, key here, is roughly symmetric. And that's roughly symmetric. It forms pretty much a hill where one side is pretty repetitive with the other. Okay? Same thing on this one. This is roughly symmetric, although I would say this would really be symmetric if I just took off that term. So sometimes you'll say roughly symmetric. Sometimes, like on this one, this is roughly symmetric, but it has this. So I might say roughly symmetric with an outlier of 68, or roughly symmetric with an outlier of 52. You could say that as well. Okay. On skewed right, again, it's going to tail off to the right. So maybe I'll write that. Tails off. Oh, you can't see that. Tails off to the right. So it almost looks like it has a tail going that way. And the same thing kind of happened on this one, right? It's tailing off to the right, so it's skewed right. Remember the key word here. Skewed right, skewed left, or roughly symmetric. Those are the 3 words, key words you need to know. Okay? Let's go to the next page here. Going back to the sad story of the 2012, that's what year it was, U.S. women's soccer team. We've got these goals on here, but this isn't the goals actually. This is the difference in goals. So this game, they actually won 13-0. This game, they won 14-0. This game right here, they lost 1-0. And it's the only one. Okay, they had a few ties, but then the rest of these, they won by that many goals. So what we're going to do to make this easy, we're going to talk about our measures of central tendencies. Okay, and that includes center. Measures of center, maybe write that in there, okay? Measures of center, which include the mean, the median, and the mode. And so if you remember, you can find all this data, just a second, I'm gonna fix this camera here, okay? You can find these by adding everything up and dividing by the number of terms for this, and I can show you real quick how that works. This is -1, 3 times 0 is 0, 6 times 1 is 6, 3 times 2 is 6, 6 times 3 is 18, 4 times 3 is 12, a 5, a 13, and a 14. And I can add those all up to get 73. And then count all the terms and realize it's 25. And divide that out to get 2.92. Yep, you can do all that. Okay. You could also find the median by just going from each side. 1, 1, 1, 1, 1, 2 more there, 2 more here, 1, 2 more there, 1, 2 more here, 1, 2, 3, 4, 1, 2, 3, 4. 1 from here, 1 from here, 1 from here, 1 from here, and you can see there it is, 2. There's my median. The mode, well, the most occurring one, of course, would be at 1 and at 3. So 1 and 3, okay? Now, I actually went and put all of this data into a calculator. If you remember how to do this, I'll show you on here, that if I go to the stats menu and I go to edit, what you'll see is I already put it all in under L1. I put all of those numbers in, okay? -1, every time it shows up as a dot, it shows up as something in here, okay? Brings me back to the top here. Remember to get the data to calculate it, I press stats again, go over to calculate, press my enter here. I get that on the screen, and because I put it under list 1, I'm going to go second L1, which of course, again, is 1 right here. If you put it under list 2, then you go second L2 and so on, okay? So that shows up on my screen. Press enter. And there it gives me everything I just got. My center, my mean, which is 2.92. My standard deviation, we'll get to that in a minute, but remember how I could go down here and it gives me the median right there of 2, okay? And then the mode you just kind of have to figure out yourself. I'm gonna come back here so I can see my standard deviation because that's gonna come up in a minute. The mean is best for data that is symmetric, okay? Symmetric data, okay? Otherwise it skews the mean. Matter of fact, so much so, matter of fact, let's put that. Otherwise skews the mean. Let me show you what I'm talking about. This is skewed right. And so that data over there is skewing the mean. If I took those 2 points out, that'd be 13 and 14 away from this total, I'd have, let's see, 60 minus 14 is 46. And 46 divided by 23 terms is exactly 2. So just from those 2 gains alone, the mean went from 2 all the way up to 2.92 because of those 2 outliers. And that's what skewed data does, okay? To use the mean is best when it's symmetric. To use the median is better when it's skewed data because, well, let's put if skewed data or outliers. And really, skewed data is because we have outliers, okay? So again, if 13 and 14 were taken out, that would be our mean. Okay. The spread here, measures of spread, down here now, measures of spread are including range. It says interval here, but this is really the range. And the range, the interval is the numbers from the range. And you can look at it here. The highest number was 14, coming back up here. And the lowest number is -1, so I would go 14 minus -1. To get the range. When there's a zap, I get 15. That's the range. The interval is just those numbers, -1 to 14. That's all it is. And goals, differentials. Or just goal differentials. Man, I can't write. Goal differentials. Okay. We got our range. Our standard deviation, again, I just got that from here. If you remember, it's that funky looking symbol right there with the sideways A looking thing. 3.545 is my standard deviation. So really, if we think back to that data that we've talked about already, with our mean being 2.92, which is right about here, within one standard deviation, 3.45, would get me out to, I'd say, so like 3 plus 3.5 is like 6.5 right here. And the other way, it would bring me to here. And I would have almost all of that data, 68% of that data is in there. It's actually higher than that because look, there's only 3 outside of it. But if I go 2 out, and another 3.5, get me to 10. And over here, I'd include one more thing, but I still got a couple chilling out here. I go to a third, and that 14 is outside of 3 standard deviations, so that is a crazy outlier, okay? Keep going here. We've got distribution in terms of how this is. What does this data look like? Does this look like it's skewed left, skewed right, or symmetric? Well, I've got these outliers over here. If I draw a picture, I can see it tails to the right. So the distribution of the number of siblings here, you know, how many siblings we have, I'd have a fun conversation with this if I was in class. How many of you have 0, 1, 2, 3, 4, 5, 6 siblings? I happen to fall under this one. I don't know why there's no marks there, but I have a real brother and 3 step siblings that I would consider siblings. So the distribution of the number of siblings is skewed right, because it tails off to the right, okay? And it's to the higher values with a median of 1.5 siblings. Right, I could enter this data as 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, 5, 6, and then find the median from that. Or again, I could just cross off kind of 3 here, 3 here, 2 here, 2 here, and these all cross off to end up right in the middle here, okay? All right, next page, just some more explanation of this stuff, okay? What does this look like? Let's describe the distribution. So really, we draw ourselves a picture, okay? And I could say one of two things. Either I'm going to say this is roughly symmetric, because it really looks like it's roughly symmetric except for this one outlier. So I'm going to write that. So height is roughly symmetric with a center about, well, what would be the center here? Let's look at it. Probably right about here. If this is 64 and this is 68, it's probably right around in here at 66. Okay, and inches, excuse me, and a range. Well, what's this going from? 72, 76, so this is 80. This down here is 52, and 80 minus 52 would be 28 inches. If you were to say on this that this is skewed left because of this outlier over here, I'd be okay with that as long as you explain it. Okay? The U.S. Women's Soccer 2012 data, the distribution of goals of goal differential is roughly symmetric right? If you look at it, it's like this. So I could also say again, it's skewed to the right because of 13 and 14, or I could say, so I'm kind of taking it two different ways, or roughly symmetric, but with two outliers. So there's multiple ways of discussing this data, okay? The center, well, if you look at the center of this, it's about right there, right? Is about 2, and range is 15 goals, right? 14 minus 1. So when it asks you to describe the distribution, you're going to tell me whether it's symmetric, roughly skewed, or roughly symmetric, skewed left or skewed right, and then you're going to tell me what the center and spread is, and the center is just basically the mean or the median, and the range is our spread, okay? So if you look at this last one, there's again two different answers. Let's draw this picture. Okay, this is talking about, looks like common stocks percent return, right? And it ranges from negative 25% all the way up to like 12.5%, right? So you could say either, and this kind of sums up what I was saying up above, how you could do either or. Either A, you would say this is roughly symmetric, but with an outlier, right? This one over here, even this wouldn't really throw it off too much with an outlier. Or you could say, part B here, that this is skewed left, because again, it is tailing off to the left, and I'm going to actually write that, because tailing off to left. Okay. This is the information you need to know. You need to know again, what does skewed left, skewed right mean? That just means it's tailing off in that direction, and you need to know roughly symmetric. Have a good day. Enjoy your project. Get stuff done today.